Okay, guys, so for activity 3, it says scale or not scale. But the reason why I'm scrolled down is because I want to read these questions before I even look at the image. Okay, so May says that polygon ZSCH is a scale copy of polygon XJYN, but Noah disagrees. Do you agree with either of them? Explain or show your reasoning. So let's look at this image. Just like what I said from lesson 1, anytime you see a grid in a math problem, it either wants you to graph something, draw something, or use it for a tool of measurement. And in this case, it wants us to use this grid as a tool of measurement. So in order for me to figure out if this is a scale copy or not, is I want to measure or take the measurements of this polygon. So what I want to use is the corresponding distances. Okay, so I'm going to take the distance from segment N to J, H to S, and I'm going to change the color. I want to take the distances from X to Y, Z to C. So let's begin. So from segments N to J, let's count. So 1, 2, 3, 4, 5, 6, 7, 8. So there's 8 units in between N and J. So this is 8 units. Now let's look at H to S, and this is 1, 2, 3, 4, 5, 6, and this is 6 units. Okay. So then I want to take the distances between the other 2 segments, and I'm doing that in blue. So this is 1, 2, 3, 4, 5. So let's see. Let me double check. So 1, 2, 3, 4, 5, 6. Oh, I apologize. Actually, 6. 6 units. And this one is 1, 2, 3, 4. 4 units. So let me make sure I double check each one, so I didn't make to ensure that I didn't make a mistake. So it's 1. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9. That was 1 off, okay. And this one is 1, 2, 3, 1, 2, 3, 4, 5, 6. Okay, that one's right. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. Okay. So now I can use ratios or see if these are equivalent ratios to determine if these are scale copies of each other or not. Okay, and how I can do that is by putting these measurements in ratio form and simplifying them to see if they are equivalent or not. Okay, so here's what I mean by that. I can do 6 to 9, 4 to 6. So I have to ask myself, if this was a fraction, 9 over 6, 6 over 4, what would be the greatest common factor between 9 and 6? What can I simplify it by? Now, I can break it down to its prime numbers, which is 2 to 3, which I could scratch out the 3's, which was left over with 3 to 2. And then with this, I could break it down to is, let me move my pen out the way. 3 times 2, 2 times 2. If I can scratch out the 2, what's left over is 3 over 2. So are these equivalent? And yes, it is. It is equivalent. And what I love about these questions where they say explain or show your work, I don't have to, if I'm not a person who's like into ELA, I don't have to write like a sentence. I could just prove my work. If I had to write it in sentence form, I would say whenever I put the measurements in ratio forms and simplified it, they both were equivalent. If the ratios are equivalent, then they are scale copies to each other. That's the way you could prove it, okay? So let's look at question 2 now. So question 2 says, record the corresponding distances in the table. What do you notice? And the corresponding distance, which we've already recorded, which is 6, 4, 9, 6. Okay. So for question 3, of course, we are at home. We don't have protractors, but of course, I don't want to just take this opportunity, this learning opportunity from you since we don't have protractors. But it basically wants me to see if they have the same angle measurement, and I'm going to show you what that looks like. So of course, I need to erase all of my scratch work, because this is trying to determine, like, can you determine something's a scale copy of another figure or polygon by just looking at the angles. So let's use orange for this one activity. Okay, so I'm going to use angle X, N, Y. And let me erase that line and do it again. So I'm going to take angle X and Y. And I'm trying to trace over the best way I can and darken up to where you guys can see. So I've traced the angle. So now I want to determine if it's going to be equivalent to the angle in the scale copy. And here we go. So what do you guys think? Let's look at that again. Okay. So are these angles equivalent? Okay, let's do another angle in this figure. Oh, let me change my pencil. And I'm going to do it like this. All right. So let's look. Let's look at this one again as well. They don't match up. Okay. So the next question, which is number 4, it says, after you use your protractor, do these results change your answer about the first question? So I want you guys to think about that, answer that in your head. Pause the video if you need to. Does this change your thoughts on the first answer? And if it changes your thoughts, think about it. Which tool or which measurement do you feel like is more accurate when determining a scale copy? So I think this book purposely tricked us to see, like, you know, want us to prove that its corresponding distances as accurate as measuring the angle to a scale copy of something. So who knows? Now let's look at number 5. Here are 2 more quadrilaterals. And it says, Karen says that polygon EFGH is the scale copy of ABCD. But Lynn disagrees. Do you agree with either of them? Explain or show your reasoning. So let's look at this, okay? the angles definitely measure out to be the same, so that it passes the angle test. And we don't even have to measure it because it already gives us angle measurements. The angle measurements match. But we can determine if it's a scale copy or not by looking at its corresponding segments, which we could look at segment AD to segment HE. We could look at segments 2 to 1, 4 to 6, and 3 to 3. Okay? So I could divide 4 divided by 3, which equals to 1 1/3. Okay? 2 divided by 1, which equals to 2. 6 divided by 4, which equals to 1 1/2. So I want you guys at home to think about this, okay? Because I'm doing this right now with you guys, and my mind is like really blown, like, wow, like what is this examples trying to tell us? So I want you guys to think about that, and we'll reflect on that tomorrow.